Hi everyone, I am demonstrating today our first assignment in CIS 589, which reads the data from a sensor attached to the Raspberry Pi and transmit the data to my computer using MQTT protocol. In this demo, I configured my Raspberry Pi as the broker or MQTT server using Mosquitto, and I used the built-in Mosquitto client on the Pi itself to publish data to a topic using Python code. And on my computer, I use MQTT Explorer to subscribe to the same topic and receive the transmitted data. First, I'm gonna show you the connection setup itself. Here is the yeah. Here is the Wi-Fi, and it's connected via this, GPIO extension board to the sensors. There are two different sensors here. Let me show you here. Yeah. There are two different sensors here connected to the Pi, one for the accelerometer and gyroscope in XYZ directions, and another ETH21 sensor to read the temperature and humidity. As these sensors are I2C devices, so they are connected to the SDA and SCL uh, buses, which is, the buses for the data and clock, respectively. Let me first stop, the camera in order to show you how the system works on action. Okay. Let me show you first the Python code. LS. Okay. Eight. Python code. Actually, I made many modifications on this code I had found on GitHub to read the data from two sensors instead of one. Uh, Also, I added and here's the class for the ETH21 sensor for temperature and humidity reading. And actually, I added the ability to first scan any attached I2 devices to my Wi-Fi and send back their addresses. Also, I have added the ability to reboot either the sensor or even the Raspberry Pi itself remotely from my PC via publishing the reboot command into a topic created specifically for this purpose, as seen here. And here is the forever loop for publishing sensor reading every 5 seconds, as seen here in this line of command. And actually, in order to simulate the real life scenario where the Raspberry Pi may be rebooted for some reason due to power outage or intentionally via reboot command, I added that Python code in the boot of the Raspberry Pi itself, so it will be executed automatically during the boot itself. Let me show you that. CD etc system. Oh, system. And here are the services at the boot sequence, and this is the service I have created. This is the one for the MBU 65, and during the boot phase, this Python code, it will be automatically executed. And also, if for any reason that the Python code doesn't initiate it at the startup, I added the subscription to the sensor commands topic to be executed at the boot phase as well. So we can reboot the Raspberry Pi remotely, even the main Python is not running. And here is the service for that one. Where is it? Yeah, this one. And here is the Python code for that purpose. Let me show that at home. Python code for that purpose. Okay. And now let's run the system to see how it works. Actually, let me, stop the code running in the background and trigger it manually to see the code output in action. Let me sudo, let me show you that. Sudo systemctl status. Okay. And this is a service, and it's running, and it's running. It is active and enabled at the boot phase itself. And here is the latest sent data. Let me stop that and here, I'll just let it send a couple of readings and I'll stop it. Okay, I'm gonna stop it. Okay, here. Actually, as I mentioned earlier, the I square C devices scanning process. This is a scanning process here, and the by found two sensors are connected already. And here I intentionally made a wiring issue to show, how the scanning and sensor and its instantiation function works. And here, that sensor has a wiring issue here, and this is the MBU sensor readings. And this is, I have printed out the timestamp, and this is a temperature reading, and this is acceleration and gyroscope reading. And this is to verify that the data is already sent to the respected topic, MQTT topic. And let me show you there in the MQTT Explorer, we have received the same reading, and this is a timestamp here. This is the last timestamp before terminating that code. This is for 2555, and here is the latest one here. Okay, and if you can notice here, the frequency, sorry, the frequency of sending the reading is one reading every 5 seconds as per my code. This is 50, and the next reading is at 55. And let me run the code again to verify the rebooting either the sensor or the by itself remotely from my PC. I'm gonna uh, run it again. Here, I'm gonna publish the remote sensor command from the MQTT Explorer. I'm gonna publish it, but let me first, you know, publish that one. Sorry, I'm gonna publish it. Okay, so see here, I'm gonna stop it. Okay, see here we are. We have received the sensor reboot command. If you can see here, yeah, this is a sensor. Yeah, we have received the sensor reboot command and immediately reinitialize the sensor. Okay, and the subscriber already received the reboot command, as well. Okay, and let's reboot the entire buy to verify that after powering up, the buy is still able to send sensor reading automatically. Okay. Let me, sorry, man. Sorry. Let me send that command, reboot the buy itself. See that. Okay. Run the command again. Okay. And let's send that. Okay. Okay. See? Yeah. Yeah, the reboot command is already received, and the buy it's already rebooted. And let's wait to come back and verify that the code itself is still running at the boot phase. I'm here. Like it's coming up. Let's restart the session. Enter my password and see. Okay, let's check. Okay, let's check. And if you see here, yeah, see now it's 30, 40 second, and it's now 45, and it's it's where we are still receiving the sensor reading even after rebooting the buy itself. And let's check the status of that one. If you can see here, yeah, after rebooting, it is enabled and running. And that's it. And thank you for watching, and have a good day. Bye bye.